Okay, so here we have a polynomial with the fourth degree, so that means I'm going to get 4 solutions. Alright, and the first thing I need to do is list the possible rational roots. Okay, and remember we're going to take the factors of the last term and divide them by the factors of the first term. Okay, so I have to list all those factors out. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Wow, that's a lot. We're going to divide it by the factors of the first term, which is 3. So the factors of 3 are 1 and 3. And then what I need to do is I need to divide each one of these numbers on the top by the denominator. So first by 1 and then divide them all by 3. So 1 divided by 1. So if I divide all of these by 1, I'm just going to get the same thing. So I'll just go ahead and list that out again. 1, 2, 3, 4, 6, 8, 12, and 24. Now I divide them all by 3. So 1 divided by 3 is 1/3. I'll go ahead and put that down here. 1/3. 2 divided by 3 is 2/3. 3 divided by 3 is 1. 1 is already in my list, so I'm not going to write that again. 4 divided by 3 is 4/3. 6 divided by 3 is 2. It's already in my list. 8 divided by 3 is 8/3. 12 divided by 3 is 4, which is already in my list. 24 divided by 3 is 8, already in my list, so I guess these are the ones. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12, times 2 because there's plus and minus. So actually 24 possibilities. Now I have to go through and test to find out which ones are actually roots. The fun part. So I'm just going to start down the list, starting with 1 and see if that is has a 0 remainder, and that would mean that it divides in evenly as a factor, and that would make it be a root. Okay, so using this polynomial up here, so 3, 2, negative 23, 2, and 24. Okay, looking for a 0 remainder. If it's not 0, it doesn't work. Okay, so just bringing down the 3, and then timesing these two, that gives me 3. And then adding these two, which is 5, times 5, add negative 18, times negative 18, add negative 16, times negative 16, add 8. This is my remainder, and since this is not 0, that means positive 1 doesn't work. So I'm going to go through and try negative 1 now. Just leave that 3 there since we got to bring that down every time. Okay, so bring down the 3, times that, negative 3, add negative 1, times positive 1, add negative 22, times positive 22, add 24, times negative 24, add 0. Since we got 0, that means it is a root. Alright, so now, that's one root. I'm going to box that in so I don't lose it. Okay, so now what we want to do is we want to do the remaining polynomial and find out what the roots are remaining. Okay, so we know that negative 1 is. Now, you should always check that again just in case it works again, because sometimes that happens. So that's my advice to you, to save you a little bit of a headache later on. So I'm going to just try it again on this remaining polynomial. So 3 minus 1, negative 22, 24. Bring down the 3 and then times, you get negative 3, add, times positive 4, add is negative 18, times positive 18, and then this is not 0. So that's a no. So we tried positive 1 and negative 1 fully. So now I'm going to move over to 2. Okay, so let's try 2. Bring down the 3, times these two, 6, add negative 5, times negative 10. Oops, this is positive 5, sorry. Times these, and that is positive 10. Add negative 12 times negative 24. Add, you get 0. Oh, yay, we found another one. Got a 0 remainder. So box that in. And then now I'm going to bring this on over to here. And then, so that's 3, 5, negative 12. There are 3 terms, so that means it's a square quadratic. Once you have it down to a quadratic, you can go ahead and use the x method to factor it. So you remember you times the first and the last, which gives you negative 36. And then the middle term comes down here, and then you do the factors of the top number. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. So you look for the pair that adds or subtracts to 5. That does not, that does not, that does not. This does, and that does not. So if I do 9 minus 4, I get positive 5. And then if I times them, I get negative 36. Let me make a little space here. Okay. And then remember, you need to divide by the first term. So dividing by 3. That doesn't divide. That gives me 3. So I write that. And remember, let's put them as factors. Let me get another marker. So now I'm going to be writing them as factors. Okay. So this one's going to be x plus 3. This one's going to be, remember, bottom number first, so 3x minus 4. And then I'm going to go ahead and write these 2 other solutions that we found over here. Remember, this means x equals 2, so as a factor I have to subtract it to the other side. So it's going to be a minus 2. So I'm going to add that in, x minus 2. Here I have x equals negative 1, so as a factor it'll be x plus 1. Okay, setting that equal to 0, and we can find all of our roots. So I'll just keep it as blue. X plus 3 equals 0. 3x minus 4 equals 0. X minus 2 equals 0. X plus 1 equals 0. I'm going to kind of do this in my head. Subtract the 3, negative 3. Add 4, divide by 3, 4/3. Add the 2, so positive 2. Subtract the 1, so negative 1. And there you have your 1, 2, 3, 4 solutions like we predicted. 4th degree.